Welcome everyone. Thank you for joining. It's lucky for you that the color of KubeCon is blue. I'm wearing my blue shirt instead of the bright purple that we encourage at Yahoo. I want to talk a little bit in general about an effort to migrate to Kubernetes that we've undergone. We have been working on a lot of different solutions for a long time, and hopefully some of the lessons here can be useful to all of you. Yahoo is a huge driver of traffic on the web, with billions of pages served to millions of users every day. We've had a long history in internet years, which means lots of different engineering teams, diverse workloads, lots of acquisitions, and lots of different legacy systems that are all being updated over time. This can get really, really expensive. We're looking for optimizations that may be large or small to increase utilization and decrease application maintenance. And Kubernetes is a great candidate for the next generation of our infrastructure. We have several teams using public clouds. We also have a large internal cloud, which is running hundreds of thousands of requests per second across many products. And over the years, we've experimented with various orchestration frameworks. We were advised to not make jokes about the different options, so I won't do any of that. But including several homegrown ones with varying levels of success. But most of our traffic still goes to directly allocated hardware in data centers. And I don't know if anyone here is using bare metal, but it's a big deal and a lot different than many of the automated setup that you saw this morning for Google Cloud, for example. There's no one-click deploy. A few percentage points difference in utilization can lead to millions of dollars of savings. So this is something we're really excited about. And a few percent improvement in usability can lead to millions of whatever happiness is measured in units. My name is Hans Kieserman, or Kieserman in Germany. I'm an architect for the engineering services team at Yahoo. We build tools that are used across the company. We spent many years building really powerful systems to get the job done. There were many custom internal products, and this makes the migration even more challenging. There even used to be an enterprise guide that said that just don't pull the latest open source thing off the shelf. Linux is an exception. Look at all these startups that had to be bought out to actually scale. And I think that's really, really changing now. Two things that have actually been around for a long time, as I'm sure you're aware. Elastic Cloud infrastructure, and also large organizations contributing to open source. Yahoo has done a lot of open source work in the grid computing area, Hadoop, Apache serving stacks, Node.js community, software build infrastructure, and more, but we have not done so much in the cloud world. And this is one story about us trying to make that transition. So whenever you're looking at a new transition like this, there are a few steps that you should really follow, and this was successful for us. Really question everything. Open it up, figure out what the inflection point will be for making the change where you need to invest first. Second, build out your team to respond to those challenges. And third, tune for the real world use cases. So you'll hear a lot of talks at Kubernetes over the next few days, today and tomorrow, to understand all of the specific features that are available in Kubernetes. You'll hear a little bit less about the pain points. So hopefully I don't sound like I'm complaining for a half an hour here, but there are a lot of other issues that we need to think through in addition to how to deploy. After you deploy, how do you route? After you route, how do you make sure that things are secure? Here's a rough picture to keep in your head for context. Hopefully this is totally familiar. If it's not, this is a little bit of a mix between the data plane and the control plane in the Kubernetes infrastructure. You can see the one master or a cluster of master servers, one of which will be the leader running an API server, controller managers and schedulers to route workloads to different nodes, and then the node itself running pods that consist of a group of containers. So the pod is created usually with an application container running the main workload, microservice, whatever it may be, as well as associated potentially authentication, logging, metrics collection, and others. And adding more functionality is easy as pulling in another image. and configuring communication with your app, such as a shared port or a volume. So as I mentioned, my goal here is to give you a sense for what the real world problems are. Beyond the how-to documentation, you can make more informed decisions about your own choices. And we'll have to answer these separately for every organization. I think all of the answers here are positive for almost everyone these days. And it's getting better every day. Kubernetes is very easy to run scripts on. It's very easy to get running in 5 minutes, but that doesn't mean it's ready for production. If you have a small deployment, you can often get away with running on a public cloud. And there are great vendors here who've been contributing a lot to the community. There's consulting from organizations at the booths outside. Don't go the bare metal route without being fully aware of what you're getting into. It can be very successful, but it requires care and time. Also, the implementation path is a critical choice, but it's not an irreversible one. A lot of organizations are looking at Kubernetes as a portability factor, meaning you can launch on AWS Kubernetes, for example, and if it gets too expensive, you could switch cloud providers, or you can bring it in-house. Each of those transitions is not cookie cutter, but it is relatively easy. We've done some tests also showing that there's no loss of performance in multiple cases. For example, running on a cloud provider, using the native cloud infrastructure versus running Kubernetes on the cloud provider itself. In our case, we found that the networking customization that we had to do in each case made it not specifically worth running in multiple situations, that we're going to continue on premises for now, but the door is always open. Beyond the organizational challenges, there's a lot of technical questions, and I believe these are some of the most critical for Kubernetes. There are also questions that are not something that Kubernetes can obviously solve directly. There's been a lot of talk of composability, small components, and modular functionality from Kubernetes itself that is not solved, does not change how fast your application runs. For example, depending on your uptime requirements, you might need to tune heavily to get the performance that you need. Kubernetes by default, or with many of the common scripts, comes with an extra couple of hops to get to your serving containers. If your app takes a long time to start, you really need to worry about the disposability of pods and implement health checks very carefully. If the health check occasionally returns a 404, you may be killing the pod, which gets very, very expensive if it's a long restart time. We had an example where a legacy package manager was touching a lot of files, and so when you would try to start many pods on the same box, you'd end up with lock conflicts. We experimented a lot with read-only volumes. We tuned the application itself. We tried hacking on the package manager, and ended up with SSDs to get over the critical threshold for that particular application. As another example, there are very successful startups out there that are running BSD. Obviously, this is not for you. We had some hosts running old versions of Red Hat, and the OS is incredibly important. We spend a lot of time catching up. There is work to do there. We can't be infinitely compatible. It's also a good idea to stay up to date anyway. I'm sure you know security reasons, performance, and general maintainability. It's much easier to resolve by being up to date and building your infrastructure to make it easy to stay up to date on a recent operating system. As another example, we have custom data centers where we run all of our software, and we couldn't easily support large numbers of pods because of limits in the routing tables on the switches. So it's little things like this that turn into big things. You can't just deploy Kubernetes itself. We have to worry about how we get enough capacity in the existing systems to deploy them and how to change configurations so that they function well. The way we solve that is by modifying rack configuration. So there's some excellent software out there, Bird, for example, that will help you allocate CIDR blocks of IPs to specific nodes and then advertise them to the switches so that we can have efficient routing table entries without using an overlay network. I'm sure because you're at KubeCon, you've heard a lot. You understand something about exactly why we use Kubernetes. But graphs like this show us the motivation for them. You can significantly decrease your overall capital expenditure and operating expenses by just increasing your utilization a little bit, like I mentioned. We've seen reductions as much as 6 to 1 in the numbers of hosts that we've been able to run exactly the same workloads at exactly the same performance just by migrating onto the Kubernetes infrastructure. And that's for a few reasons. First of all, sharing compute resources with multiple applications obviously helps a lot, especially if load on your applications is not tightly correlated. You need to be very worried about whether everything is going to spike at the same time or whether you have distributed workloads that can be allocated together. Everything else can also be shared. So excess hosts, as we mentioned here, that you might be using for business continuity planning for reserve that may have very low utilization in the normal case. Instead of having many separate pools, one for each application, that are all pre-deployed and just waiting, now you can have those shared, waiting in the wings with a much lower number of total hardware. Also, sharing is valuable, but it's not entirely required. So with 1.6, the affinity and anti-affinity have gone into beta. We saw some demos earlier in the keynotes that showed how to allocate specific workloads to specific pools of machines if necessary. And the auto-scaling features really help with that in a way that you can have critical workloads, for example, on the Yahoo homepage. They really like to have separate compute so that nothing else can possibly affect the latency of user requests and then overflow into excess capacity as needed. So there are a few other things. Beyond just performance, there are a lot of features that Kubernetes provides that allow dynamic automated management of large production clusters and great tooling that can help reduce the overhead for your teams. It's this wonderful dichotomy where it requires some expertise to run, but even if you're not an expert, you can get a lot out of the box. There are powerful features to accomplish great things. It encourages you to learn, and it points at what's really important so that you can worry about innovating on your own software. Unified catalog of infrastructure here, what I mean by that is that there are side benefits that you might not think about. In addition to smoothly operating the software that you have, you can also have all of your software in one place. The API server allows you, for example, as OpenAI mentioned, to inspect everything that's running and build dashboards that can show you the entire list of dependent operating systems for security scans. You can find developer teams easily, which is actually a problem at larger organizations. When we do our refreshes across the company, the Kubernetes API itself allows us to get a lot of data about exactly what's going on in a way that chasing down individuals makes not so efficient. The second thing you want to do after trying out the demo is to work out the scope of your Kubernetes goals. It's a great reason to clean up your house. So if you can launch one or more Kubernetes instances with the right safeguards, then you have this blueprint that lets you deploy new applications quickly. Based on the current state of your infrastructure, what can you reasonably expect to achieve? Common sense is that stateless microservices will be fast and easy. Not everyone is there yet. Try containerizing what you've got. Release one small thing to production first and then expand. And the stateful ecosystem is getting better and better. Go slowly and try out the new features that Kubernetes is providing. So rule number 2, build the team. We found that Kubernetes is easy enough for either developers or production engineers to operate. It does take special knowledge to really do a good job. Specifically in these 3 areas, foundational networking, containerization, and monitoring and logging have been challenges for us. So does your team understand, even outside of Kubernetes, what L3 and L7 are and how many hops it takes to get through a DNS request? Can you efficiently process large volumes of logs? Do you have Splunk or Fluent already installed in your infrastructure? It's not enough just to read the documentation. We found that hands-on practice, local experts, and lots of testing, like anything, make the biggest difference. So here are 3 best practices that I would really encourage. First, it can be tempting to take your team and encourage them to all go read everything they can find. This is not efficient. It certainly works. But finding local experts, delegating individual components of the system to one person and then having them roll that knowledge out across the team is the best. Kubernetes the hard way is still the canonical source. Kelsey Hightower is a national treasure. It is really not that hard. There are very clear instructions on how to do everything, and it lets you understand at a really basic level what container networking looks like, how the system is allocating tasks across pods. Second, everyone takes a turn on call, and that means everyone. That means leads, that means new people out of college who've just joined the team. This is incredibly motivating to learn the critical things that you need to know. We initially launched with a 1% bucket for a tiny little app and then expanded as we went further. And that 1% makes all the difference. There's a huge difference between being 100% ready with 0 production or being 50% ready with 1% that's giving you data. It's surprising to me how often you see questions on the Kubernetes Slack that say, my cluster doesn't work, and you say, okay, go run journal control and tell me what the logs say. It may be a little bit different than many people have experienced before in terms of where logs are placed, how to access a cluster, and these are just foundational things that are incredibly useful, especially before you've set up any kind of log processing. And then third, build community in your organization. Brown bags, tech talks, coming to meetups, events like this, and the Kubernetes Slack channel itself is incredibly welcoming. We also had a challenge to gather support from management. In order to build the best possible investment case, we got a lot of data. We ran JMeter tests that validated many of the performance claims of the Kubernetes system, and have seen, for example, pods coming up in seconds with thousands and thousands of pods on one machine. We set up a working group to work directly with high-level management to evaluate the whole landscape and make clear technical recommendations to the team. And then in parallel, as I mentioned, production data is really what is valuable and communicates the loudest. We recently had a major event, news event in the past few weeks, and saw the horizontal pod autoscaler operate absolutely perfectly with very little production experience, with very little incident. One of our engineers turned it on. We didn't even know it was on until afterwards, and the team had monitored it and rolled it out quickly. And then we can go up to management and say, hey, look at the value that Kubernetes is really providing here. There's also constant discussions going on in any large organization about whether we should be building more on-prem, which cloud provider we should be choosing, and this kind of ongoing data contributes a lot to that. A few bumps that we hit in the road. I mentioned our package manager gave us some trouble early on. A lot of the application level details in containerization really cause the main kinds of challenges that we've experienced versus Kubernetes itself. It's important to set up defaults in your system that don't cause disasters if something goes wrong. If you run delete commands manually using kubectl, you can delete objects in production if someone doesn't have their configuration set correctly. Guess how we discovered that? If you haven't already set up deploy automation and trained yourself to always use it, you need to do that first. Our clusters themselves are managed using Chef, and then applications are built with an automated production pipeline, a little bit like Heroku, that calls kubectl to deploy. There's also Helm, for example, as a package manager, which helps a lot with that. And then access to the production clusters themselves, sudo considered harmful, is problematic for the same kind of reason. You need alternate methods for debugging and maintenance with Kubernetes. kubectl exec and describe are really fantastic. And then tools like Heapster, Sysdig, Splunk, you should remember those names and try them out. Okay. So rule number 3, tune for the real world. As you might be aware, Yahoo has had some security challenges in the past. It's really, we've always taken it seriously. There have clearly been some problems that are being solved, but also it's lit a fire under everyone to really take security absolutely seriously. This is our higher than #1 priority. It touches product development and infrastructure. So this morning Clayton mentioned that security is boring and depressing, and I think that's absolutely the opposite of what it is. This is a cloak and dagger spy kind of thing, so you can think of yourself as a secret agent. And also it tends to be something really interesting about the infrastructure that you didn't understand before. There's been a lot of discussion lately about Docker networking and how to really make that secure. By default, using a bridge network keeps you open to ARP spoofing, for example, in certain cases. It's a cultural change. It's not something you can just paste on top. Frequent manual review, automated deploys, and modularization also provide benefits downstream to product development, and you need to take them seriously. So these are high-level steps in our pipelines that help us ensure security. I'm not going to talk through every single one, but hopefully recent software is obvious. We'd love to get to unikernels to minimize exposure, but that's still a long way away. Deploy automation may be a little bit less obvious, but it does encourage good practices. It allows frequent software updates. It allows people who are not on the team necessarily to get involved in security. If automation is the only path to production, it also makes audit a lot easier. You can just look at Git repos and know what's going on. And it means that any user action on the box is going to be something unusual that you can call out for alerts. Image scanning, I'm surprised at how few teams I've talked to do this. There's a product called Claire from CoreOS, which makes it easy. You really want to know where your images are coming from. Just pulling something off of a public registry isn't necessarily going to be any good. You have no idea what's in it. And you can scan for CVEs using a bunch of available tools. Cluster security means a lot more than just pod security policies. So you should look at pod security policies in Kubernetes. That's how pods interact with each other. But also think carefully about your networking model. It also means that some of the Kubernetes components are not secure by default, and that was mentioned this morning as well. We don't want to break existing infrastructure or existing deploys, but network ACLs like IP tables to prevent systems from talking to each other when they shouldn't be is very important. We've locked down our etcd servers so only the master can talk to them. Kubernetes secrets, you may or may not know, are stored in plain text. So if you want to do anything with them, it's a good idea to add an extra level of encryption on top. There's a Kubernetes dashboard that comes by default with the system, although it allows everyone to see everything that's going on in the cluster, and depending on the state of your system, you may not want that. And then basic security practices, running SSL everywhere, for example, should be followed. These are a few of the other issues that we treat as major priorities. In particular, we've invested a lot in migrating to it. So I mentioned containerization. There's a lot of standard steps across applications. You can build a common base container that everyone can migrate to easily without making too many changes to their application. We're investing heavily in automation up front to minimize cookie cutter work so that people can really spend their time testing on Kubernetes rather than spending months going through a porting project. And then, as I mentioned several times, reliability really gets to the core of what we're looking for in anything new. You can quickly start thousands of pods in a few seconds if the application itself doesn't cause more performance lags. That can bring a lot of security with it. If you can say, I might get a traffic spike, or my software is dying frequently, to know that it's easy to bring something back up quickly using software rather than waiting for an operational page. It adds a lot of confidence in the process. Okay, quickly back to the original image. So these are the components that we have added in our system. And I couldn't show every configuration option that we've added. And that's a point I want to make on purpose. that there are so many things you can do just with editing YAML files, and then obviously checking them into Git and deploying them under automation. But most of the work we've done, like quotas, admission controllers, labeling pods for allocation, are just tuning common parameters in the Kubernetes ecosystem. Most of what you want to do is already supported natively. There's a few extra components that fit into our world. So we added a custom routing layer based on ATS and authentication via an external system that I'll talk about in a minute. We were easily able to add homegrown monitoring that we've supported for a long time that has extremely high performance just by adding another container to each pod and sharing a volume to pass data around. And then we're making heavy use of Splunk and Sysdig and trying out a lot of the new functionality that we're learning about here to get as much data as we can. So the networking step, we've worked really hard to get it right. We have the luxury of our own data centers, which makes customization a lot easier. One IP per pod means lots and lots of routes, and they're changing very frequently. So Apache Traffic Server is a product that's public that performs really well. We created a plugin that will watch the Kubernetes API for changes and update routing to specific IPs as a load balancer to send traffic directly to pods rather than going through intermediate steps. And then there's a custom ingress provided in Kubernetes that we add metadata to add new CNAMEs, for example, endpoints to route to those pods. Finally, just to mention, the authentication tool is called Athens, and it's public on GitHub. It allows you to encapsulate user management externally to the cluster. So RBAC is coming out. This overlaps with some of that functionality. But we feel that there's a lot of value to have authorization and authentication in one system and to have it external to the clusters. Or I personally feel that. It means it's easy to manage cluster access and namespaces without getting involved in a deploy and across any possible installation you may have. We've created a Kubernetes webhook that supports this authentication method. We're considering that for open source as well. And it means that we can prevent access to namespaces based on the user identity or the pod identity without too much trouble. There are three essential buckets to what we're doing with Kubernetes right now. One of them is our main serving infrastructure. One of them is feed processing. And the last one is a build system that we use internally that was recently open sourced. We still have a very small rollout. I have to admit, there are thousands of RPS coming through the system and hundreds of thousands of more that we are working on. This is something that is very new to us, as I'm sure it's new to many of you. And it's been successful so far, so we'll see how it goes as we get bigger. You should also check out screwdriver.cd for other projects. That's something that we use successfully and can improve anyone's infrastructure. I'd like to close out with a quick list for Kubernetes based on my own personal needs. And hopefully all of you can just deliver that for me. Thank you very much. We're working on contributing back. One of the best parts of the ecosystem is the incredibly welcoming community. But these stuck out as particularly near-term efforts that would make the experience better, that we'd like to help improve. First is a deeper analysis of the product from security perspective. This is something Clayton also mentioned. I'm happy to hear that it's a community effort. SIG-Auth and SIG networking both get involved in security. There's a lot more to the entire infrastructure that needs to be considered for really hardened systems. There's a lot of knobs that you could possibly get wrong, and we'd love to have an easy menu of recommendations for making that better. That means pod security policies, resource quotas, image policies, and so on. 1.6, I just noticed, actually will not match unauthenticated users anymore with the star. You have to explicitly allow them in, and I think that's a great change. Blue-green deploys are something that we use heavily, we like a lot. It means that you can push an entire system to production and test it before end users see it. This is something that's tightly integrated with networking, so there are reasons why it's not part of Kubernetes yet. And in fact, several vendors, M.2, OpenShift, can provide some of these features. I'd love to be able to see this in more open source products as well. And then there are so many networking tutorials, it makes your head spin. So I think they're all great for their own reasons. It takes a lot to get through it, and so working out which ones are the best and how to make use of them would really be helpful, especially for a lot of developers without the operational background. We were talking around the water cooler the other day and thinking that what we really need is auto-scaling for engineers. If you could set your image to be, Kelsey/Hightower, and then max nodes 40 or something, that would really make a big difference to our productivity. I'm not sure that's coming anytime soon. Thank you so much. We are on GitHub. We are always looking for people interested in Kubernetes to join us, and we'd love to hear about your experiences. Thank you.